we have already idea about Newton's law of motion. So when we study motion of an extended body by using Newton's law, the question arises at what point of the body the force is actually applied and acceleration of which point is being considered. It is found that there is a one point of the body whose motion is exactly same as a point particle having mass of the body and experiencing the same force. So today's topic is center of mass. Center of mass of a body is that point at which the whole mass of the body is supposed to be concentrated. Okay, so at one point the all mass or whole mass of the body of the system is to be concentrated. Also, it is a position defined related to an object or system of objects. It is the average position of all the parts of the system weighted according to their masses. In another word, mean of center of mass in physics. Center of mass of a distribution of mass in space is the unique point where the weighted relative position of the distributed mass sums to 0. So this is the point to which a force may be applied to cause a linear acceleration without an angular acceleration. So next point is, why do we study center of mass? Mathematically, it is the point at which the torques from the mass element of an object sums to 0. The center of mass is useful because problems can often be simplified by treating a collection of masses as a one mass at their common center of mass. The weight of the objects then acts through this point. Calculation in mechanics are often simplified when formulated with respect to center of mass. The center of mass is useful reference point for a calculation in mechanics that involve masses distributed in space, such as the linear and angular momentum of the planetary bodies. In orbital mechanics, the equation of motion of planets are formulated as a point masses located at the center of mass. We know about frame of reference. For this, see my other videos. The center of mass frame is an inertial frame in which the center of mass of a system is at rest with respect to the origin of the coordinate system. Then, center of mass of two particle system. So for that, we consider two masses m1 m2 at points A and B respectively as shown in figure. So let r1 r2 be the position vectors of the two particles drawn from the origin O. Let capital R vector be the position vectors of the two particles situated at point C. That is for the center of mass. Okay. So center of mass can be calculated by taking the masses you are trying to find the center of mass between them and multiply them by their positions, and then you add all these masses together and divide that by the sum of all the individual masses. So as per my statement, you can see r vector is equal to m1 r1 vector plus m2 r2 vector divided by m1 plus m2. So this system is for two particle system. So center of mass for the two particle system. For this, we consider two masses m1 m2, respective positions of that masses, and divide with addition of both masses. Okay, so I repeat my sentence. Center of mass can be calculated by taking the masses you are trying to find the center of masses between them and multiply them by their positions, here r1 and r2, and then add this individual part m1 r1 plus m2 r2 and divide by the sum of all the individual masses m1 m2. Okay, so this is for two particle system. So for n particles, the position vector of their center of mass is given by, okay, so just changes is here n particles. So position vector for n particles, so just m1 r1 plus m2 r2 up to mn rn. Similarly, it's divided by m1 plus m2 up to mn. Same formula. This is for two particle system and this is for n particle system. Then we can write in general form. Okay, this formula, n particle formula, we can write in general form. Here we use I for that. Okay, and we can just change this part by writing m. Okay, summation of I is equal to 1 to n mi is equal to m. Why? Because we are consider m as a total mass of the system. M is equal to m1 plus m2 up to mn. So addition of all the masses is equal to m. It is the total mass of the system. Then coordinates of the center of mass of the system. So let x1, y1, z1 and x2, y2, z2 up to xn, yn, zn be the coordinates of the n particles, and xcm, ycm and zcm be the coordinates of the center of mass of the system. So for x coordinate of the center of mass is given by xcm is equal to summation of I is equal to 1 to n mi xi divided by m. The same formula. Okay, so this is for general and this is for x coordinate. So we just write here xi instead of ri. So similarly for y and z coordinates. Last is the application part. So I given here two application. First is automotive application and is aeronautics. So automotive application. So engineers try to design a sports car so that its center of mass is lowered to make the car handle better. So in aeronautics, the center of mass is an important point on an aircraft which significantly affect the stability of the aircraft. So to ensure the aircraft is stable enough to be safe to fly, the center of mass must fall within the specified limits. So this is the basic complete picture of the center of mass. Thank you for watching my video.